Alright, so what we have here is the same exact crosstab that I had on the slides, just drawn out on this piece of paper. So here we have our observed frequencies, or F sub O, of 17, 12, 8, and 16. These are our row marginals, and these are our column marginals. So just to reiterate, we get our row marginals and column marginals by adding across and adding down. So 17 plus 12 is 29, 8 plus 16 is 24, 17 plus 8 is 25, and 12 plus 16 is 28. And then 53 is the total number of observations we have, and you can get that either by adding 29 plus 24 or by adding 25 plus 28. And so this is also just n, so our total number of observations that we have. So to calculate an expected frequency, we're going to use an expected frequency equation. And again, your expected frequency refers to the number of observations you would expect to find in each of your cells if there was no relationship between your variables in the population. So if there was no relationship between gender and having been in a fight, how many people in the class would we expect to be male and have been in a fight? How many people in the class would we expect to be female and have been in a fight? How many people in the class would we expect to be male and have never been in a fight? And then how many people in the class would we expect to be female and have never been in a fight? So it's assuming a world in which there is absolutely no relationship between these two variables. We'll be using that later on to test a hypothesis related to whether there's likely to be a relationship between those variables. But right now, just the definition for it is, in a world where there's no relationship between your two variables of interest, how many observations would you expect to appear in each cell when you take a sample from that population, from that world? And our expected frequency equation looks like this, where for each cell, you take the row marginal, multiply it times the column marginal, and divide by the total number of observations that you have. So you get an expected frequency for each of the cells you have. Alright, so we have 4 cells here, and we're going to find an expected frequency for each one. So we'll start with our first cell up here, which is male and having been in a fight. So for this cell here, we need 2 things. We need our row marginal and our column marginal, and then also our total. So 3 things. So our row marginal is going to be the marginal for the row that our cell is in. So we're interested in our top left cell here. Our marginal is going to be this marginal for this top row. So our row marginal is 29. Your column marginal then is going to be the marginal for the column that the cell is in. And here the marginal for this column is 25. Then we're going to divide those 2 things by the total number of observations that we have. So we have our row marginal, our column marginal, and our total number of observations. And again, that's to find the expected frequency for this cell right here. So if you do this math, it comes out to about 13.7. So that means that if there's absolutely no relationship between being male or female and having been in a fight, so if you couldn't predict one of these things from the other in any way, we would expect to see about 13.7 people in our sample be male and have been in a fight. So what you can see here is that we have more people in this cell than we would expect if there was no relationship between these variables. Now we can also find an expected frequency for each of our other cells as well. So this one is our observed frequency, and that one's our expected frequency. So now let's move over and we will do male, but no fight. So now we're in this cell right here. And so we need our row marginal and our column marginal. So to start with our row marginal, we're going to go across the row, and the marginal for this row is 24. So we'll plug in 24. The column marginal, we're in the same column here, so our marginal is still 25. And we're going to divide by 53, which is the total number of observations that we have. If you do this math, so 24 times 25 divided by 53, you come out to about 11.3. So our expected frequency for this cell is 11.3. In other words, in a world where there's no relationship between gender and having been in a fight, we would expect to have 11.3 people in the class survey who were male and had never been in a fight. So what you can see with our observed frequency is that in this class we have less than we would expect if there was no relationship between these two things. Alright, so keep going. I'll speed it up a little bit here. So now we're going to fill in the expected frequency for female and fight. So we've got our row marginal here. We're in the top row now, so our row marginal is 29. But now we're in the second column, so our column marginal is going to be 28. So we're going to plug those in. Total number of observations is still the same, so we're going to divide by 53, which is our total. Do this math, 29 times 28 divided by 53, and you get 15.3. So here we had 12 people in this cell, but if there was no relationship between these variables in the population, we would expect to have about 15.3 responses fall into this cell here. Our last one, female and having not been in a fight. We've got our row marginal for this cell is 24. It's the one that's at the end of this row. Our column marginal down here is 28. And we're going to divide by 53 again. So we do all this math. 24 times 28 divided by 53, and you get 12.7. And so our expected frequency, or the number of responses we would expect for female and have never been in a fight, if there was no relationship between gender and having been in a fight in the population, the number of responses we would expect to see in our sample here is 12.7. Alright, so as I said before, the chi-square test is going to be based on the differences that we see between our observed frequencies and our expected frequencies. And just as a quick preview here, where this is going is that the bigger the difference between what we expect, if there's no relationship between the variables, and what we actually see in our sample, the more likely it is that we can, sorry, let me just start that sentence again. So this hypothesis test is going to be based on a hypothesis that there's no relationship between the variables. So we're going to look at what we would expect if there was no relationship between the variables. And then if what we actually see in our table is very different from that, we'll have evidence against the idea that there's no relationship between these variables. But I'm going to go back into the slides now, say that a bit more formally, and then we'll come back and do an example of this hypothesis test.